All right, so this video is going to have questions 16 through 20, and I'm recording this from home. That's why it's a little bit different as far as the layout. But nonetheless, let's get to it. So number 16, it says, determine whether the relation is a function. Okay, so looking at this, we know that it's a relation as of right now, so that means it could be points just all over the place. And if we were to map them out, it'd be like 1160 would be right here, and then 1261, 13 a little higher at 62, and 14 at 67, which would probably be higher. And again, this is 61, 62, and then 67 up here on the y-axis. And then you get the gist of it. 15 will be at 69, and 16 will be at 69. So let's put 16 here, and 69 is about here, and 69 is about right there. So nonetheless, they failed the vertical line test. Like if I had a vertical line that I was just scrolling over to the right, none of them would, like we said in class, double beep, if you will. They wouldn't have one x value has two different y values, thus failing the vertical line test. So you can graph it this way if you like, or if you want, you could just look at the x's that are given and the y's that are given. Okay, so notice that when you're given a table like this that is horizontal, the x is up top and the y is on the bottom. In Algebra 1, we were used to seeing vertical tables where the x values were given here and the y values were given here. This is pretty much the same, only it's turned on its side. Okay, so the relation is, in fact, yes, it is a function because it passes the vertical line test. All right, so let's look at number 17 now. So number 17, they give us a function, and then they want us to evaluate it at x is equal to -5. Okay, so the function they give us, the name of that function, like we talked about in class, is f. So we will use this function for this specific value that we're trying to find. We're trying to find what is the y value on f when x is -5. That's what we're looking for. What is the output? In other words, what does this equal right here when we use this function right here, aka the machine, and we're plugging -5 in everywhere where we see this input value of x. Okay, so let's go ahead and build it. We have -8 parentheses. Remember on the test, use the parentheses very, very wisely. We're looking for f of -5. So if x is -5, we're going to place it right here in the machine, otherwise the function. We have -8 times -5. And we're trying to see, can you use parentheses appropriately to know that a negative times a negative will be a +40. And then you have the -7 still left over so that you get 33. But please don't put 33 like this on the test. I want you to make sure that you know what in fact it represents. So you're going to put f of -5 is equal to 33. It's basically saying when x is -5, the y value is 33. This is what you did back in Algebra 1. Now we're just refining it to a different level of function notation of saying f of -5 is 33. Okay? All right, so now let's look at number 18. Number 18, I'm given an h of x function. So the machine's name is h of x. And we want to find what is h of this stuff right here. Okay, so don't get confused on which one is the function. So it's determining, or it's defining h of x is this. So we'll build our machine, and whatever this variable is, if it's x, if it's r, if it's p, whatever it is, that's what we're going to look at in the machine and leave parentheses for an input value to be placed in there. So you notice how I just still wrote this r. I didn't put parentheses where r was at because the input variable is x, and that's how it's defined in function notation right here. So now, this is h of x, and we're looking for h of all of this stuff right here. So we're going to put where x goes 4r squared plus 2r, and then we're going to simplify by distributing this 7 onto these two terms. And 7 times 4 would be 28r squared, and then 7 times 2 would be 14r. And then we still have this 6r in the original equation that we're going to basically just bring down and end up simplifying. so that you have 14 plus 6 is 20r. Those are combining like terms. And that's all we can combine because these are different terms. This is an r squared term, and this is an r. So you're going to leave it just like this. But again, just like I said in good practice on number 17, we're going to write it as f of 4r squared plus 2r. Sorry, h of 4r squared plus 2r is going to equal to that. All right, so now let's move on to number 17. So actually, I'll just scroll it down. All right, so make a little bit more room. All right, so number 17. Number 19 says, find the domain and range of the relation. Okay, so right now it's a relation, aka just points that are given, and we want to find the domain and range. Because this is discrete, nothing's connected whatsoever, they're all separated points and just points. We're going to list them as the following. The domain will be a set, and the range will be a set. Remember, the domain is just the x value. So we're talking about -4, negative, this is like, so each line is 2 and this is 4. This is like a 2.5. So you can estimate it, you can roundabout estimate, and if you're pretty much close or anywhere near the number, like on the test, we will give you the credit. But make sure you look at the scale, because if it's not like this and it's exact, we would need the exact. So this is about -2.5. It's also, well, let me write the -4 first. -4, -2.5. We have one at x is equal to 0. That's this one right here. And then we have the +2.5. And then we have the +4. Okay. So let me make some room right here, a little bit more. And we'll say +4. So there's 5 x terms. Now we'll look at the y terms. Okay, so we were looking at the x-axis just now. Now we're going to look at the y-axis to determine what are those y terms. So if this is 2 and this is 4, 6, 8, we can say that this is about 0.5. So let's say the first y value is 0.5. And then these other ones are going to be about 1.5. And we just have to list it once. We don't have to list it twice because it's still the same y value. I know that there's 2 points, but because they're the same number, we're just going to list it once. And then finally, about right here, looks like it's between 4 and 6. So we're going to say that that's going to be about 5. So those are the 3 y values that you see as far as the range in this relation. All right. So now let's scroll down and let's go to number 20. Find the domain and range of the relation and determine whether it is a function. Okay, so the domain and range of this one, first of all, this dashed line that you see, it's called a vertical asymptote. And we will learn this later throughout the year, what it represents, how we solve for it, so on and so forth. But for this graph, all we need to determine is that this line or this curve looks like it wants to get very, very, very close to this vertical line. Like as it's going to the left, it's getting very, very extremely close to x is equal to -3. It will never touch, but it is going to get infinitely close. So the graph looks like this per se, and it comes all the way down, and it will approach the x-axis, but actually never hit. So there is another asymptote right here, which is the x-axis, aka y is equal to 0. Okay, so this vertical line here was x is equal to -3, and this horizontal line is y is equal to 0. And again, this blue graph looks like it's getting really, really close to both of these asymptotes. So we're going to describe the domain and the range accordingly. Let's go ahead and start. We have, so this is not going to be in braces as far as like number 19 was up here, because this was discrete. And this is not in braces because it's not asking it to be in set notation. So because it's not asking for a specific way, I'm going to go ahead and use my default, which is interval notation. So we're saying that it looks like it wants to start at -3, but it doesn't touch. It doesn't have an endpoint that's closed off and then goes to the right, okay? Because of that, we are going to treat this vertical asymptote almost like it was an open dot, like it was an open circle, that it infinitely gets close to it but doesn't hit. So it'll be open at -3. And then it's going to go on to infinity forever because we're talking about the x values, okay? Again, scanning with the vertical line from left to right, this is the lowest x value all the way to the highest x value. Now, if we look at the range and we're scanning with a horizontal line going from bottom to top, the very first y value looks like it wants to be at y is equal to 0, but it doesn't hit y equals 0. It gets really, really close forever, but never hits. So we're going to treat that like if it was an open point and then going upward. Okay, so we're going to have parentheses at 0. And again, these are y values. And then it goes forever up to infinity. So that would be the range shown there.